In this video, I'll tell you how to find shadows of rectangles, and you really need to see the other four videos in this series in order to understand this. And it's in my book, Ellen's Guide to Casting Shadows, which is only $5. I'm going to talk about two different types of rectangles. There's the upright rectangle that's perpendicular to the ground. If it has a hole in it, we think of an arch, an open door, or a window. If it's floating, meaning not touching the ground, then we think of a sign. There are other floating rectangles. There are ones that are horizontal or parallel to the ground, like the bench or a tabletop. And there are some that are not parallel to the ground, like a kite or box flaps. I'm going to show you how to find window light within a shadow. First, start with a rectangle in one-point perspective that goes to a vanishing point on eye level. Then use both sides to find light triangles so you can find this intersection and this intersection. Connect them together and you have the shadow of the rectangle. Then cut out the window and find light triangles from the top of the window and light triangles from the bottom of the window. And then you have a little patch of window light within the shadow. And to check your work, these edges of the window light, the rectangle, and the shadow should go to this vanishing point, whereas the shadow and the window in the shadow go to the shadow vanishing point, or the shadow direction underneath the light. These are upright floating rectangles, meaning they don't touch this casting surface. This one is parallel to the wall and this one is not. So in this first case, the wall and let's call it a sign, goes to the same vanishing point. Set up the seat line, and then the shadow lines happen to be horizontal here. They go up until they intersect the light. So the shadow ends up being parallel to the wall. Now, an upright floating rectangle, not parallel to the wall, I recommend numbering the corners. So number 1 here goes to intersection 1. Then the rest of this vertical pole the shadow travels horizontally and then vertically up to intersection 2. This horizontal pole from 2 to 3 creates a diagonal shadow from 2 to 3 here. And then the last vertical pole goes vertically down to intersection 4. And when there are no other intersections on that plane, just continue in the same direction until we reach the edge of the wall. Then it goes to intersection 5, which is part of this horizontal pole. For front lighting, I first set up the rectangle so that it converges toward this vanishing point and drew the shadow that converges toward the shadow vanishing point. The top of the shadow here will go toward the vanishing point for the top and bottom of this rectangle. To finish front lighting, determine where you want the pseudo-sun and have light rays go through the tops of the poles and shadow lines go through the bottom, and where they intersect are 2 points on the shadow. This one is the same thing, except that you have to establish seats for this floating rectangle. And the seats go to the same vanishing point as this rectangle. And then you do the same thing. You have light going through all 4 floating corners, which are not attached to a surface, and shadow lines going through the seats. And where they intersect gives us points on the shadow. Horizontal rectangles that are parallel to the ground are common, like the seat of a chair or a tabletop. And all you need to do is use the legs as poles, so you have shadow lines going through the bottom of the legs and light rays going through the top to find intersections on the shadow. And this is the same thing except with side lighting. This tabletop is a horizontal floating rectangle, and I'll show you how to light it with 2 sources. Here I found the shadow for the first light source using the legs as vertical poles. Then I overlap the second shadow onto the first, and they each lighten the other's shadow. In other words, this orange light here lightens the shadow that is created by this light, and vice versa. So the only part that's the darkest is where neither light reaches, the part that neither light reaches, which is right here. The problem with this shadow is finding the shadow direction. So first find the light rays from the tip of its wing to the tip of its shadow, and from the leg to its shadow. That tells us that the sun is in the upper right and the sun rays are parallel. That means the shadow direction must also be toward the right. So I chose a modestly inclined shadow direction to finish these light triangles. The shadow direction must all be parallel because the light rays are parallel. And the proportions on the light triangles should be the same. So let's say this is twice this. Then for this light triangle, this height should be twice this length. Box flaps are a good example of floating rectangles that aren't parallel to the ground. So let's take this front flap and give it seats. Although it's unclear exactly how far down the seats should go. So let's then go to the shadow direction, which would be underneath vertical edges of the box. So that one shadow direction would be here. And using this corner, we can get another shadow direction that goes like this. And they're parallel because you see the light is parallel. Once you have that direction, then we know in order to get this point, the shadow direction must go like this. So this would be the end of the seat, and we would then connect it to this other seat here, and then we can find the shadow direction and the light to find this point here. For this picnic table, we can find the light direction by connecting points on the table to its shadow. But it's unclear where the shadow direction is. And there's only one place where we can find it, and that's at the corner of this table in this direction. The shadow goes in this direction. So when we set up seats, we have to make sure that the shadow direction parallels this one because the light rays are parallel. When you have a complex form like this, break it down into its components. So you can start with the vertical poles, which are the legs, and find their shadows. Then you can go to the horizontal square and find its shadow. And these two are usually look about the same if the two surfaces are parallel, which they are, and if the light rays are also parallel. Although the shadow is usually a little wider than the seat because it's further from eye level. And then finally do the back of the chair. You can do it upright, find the shadow of an upright back, and then you can just twist it back a little bit to account for this incline, and do the same with the shadow. To find this window light, let's start with the two intersections for the base of the window, and that gives us intersection 1 and 2. Then get intersection 3 over here, and we know that this line is cast by this vertical side of the window. This must go in this direction because it's cast by this horizontal pole, so it has to be converging or parallel. And it lands on point 6, but we don't know how to get to point 5. So go around the other way whenever you're stuck. And so for number 1, just continue the shadow line until it hits the wall. Then it goes vertically up because it's being cast by this vertical side of the window. And then we can find intersection 5 and connect it then to 6. Remember my book on Amazon, which is only $5, and please remember to subscribe.